Our next speaker, ladies and gentlemen, is Dr. John Peter. He is the chairperson of Varsha Bioscience and Technology, India Private Limited. He also happens to be the vice president of Bio Input Producers Association, we commonly known as BIPA. He has served as he is the scientific advisor to the research advisory board of the Tocklai Tea Research Association. He has recently been awarded the Lifetime Achievement Award for promoting biocides from the Dr. B.V. David Foundation. Ladies and gentlemen, Dr. John Peter.
Good evening, ladies and gentlemen who are shouldering part of Indian agriculture, and my earlier speakers. And I'm going to talk to you about technological innovations in microbial products, the unlocking the power of uncertainty. First, let me explain what is the uncertainty we are facing. There are few uncertainties I have projected: nutrient imbalance, induced imbalance, biotic and abiotic stress management, climate resilience cultivation, pesticide residue and pathogens, nutrient-rich quality produce. Of course, this nutrient-rich quality produce is a different part altogether, and how we are missing this nutrient-rich quality produce by adopting various technologies. All of you will be aware of it, and one by one I'll explain. And first and foremost is on microbials. Microbials, now they are covering biofertilizers, biopesticides and biostimulants also. In India, it has been listed as a biofertilizer and biopesticide, and government also agreed to include microbials as a biostimulant. So thank you very much for BASAI for the constant effort along with BIPA to convince the government that microbials are one of the important biostimulants. So what is the first and foremost is the nutrient. So if I want to talk about the biofertilizer, I need to talk about the nutrient also. Most of you might be aware what the nutrients are. And when we are talking about the nutrients, India and China, the consumption wise, India and China are the foremost two countries that are consuming the maximum nutrient, apart from United States and Western and Central Europe. You see the trend of nutrient consumption across the globe. And of late, from 2017 onwards, the consumption is becoming a plateau. So now it is 0.2% growth per annum of nitrogen, 0.1% in P, and it is negative minus 1.2% in potash. There are various reasons for this stable or declining consumption of fertilizers. When it comes to the economics, you see in India, we have urea, DAP, MOP, NPK combinations. So the production versus consumption, and there are lots of gap between them, and the import is being carried out because of the less production capacity in India. So this is government also spending lots of money on the form of subsidy, and we are having the import revenue loss. So what is the elimination factor? Eliminating the uncertainty. So now we have nitrogen, phosphate and potash, and we also have effectively integrated the biofertilizers. China was the foremost and followed by India, and we are now the leaders in integrating the biofertilizers. We have mycorrhiza, we have N bacteria, P bacteria, K bacteria, zinc bacteria. All these bacteria are being carried out, formulations are available in India, and a few of the leading companies are also coming forward and trying to sell this product across the country. But will it be sufficient for us to meet the target? Say, for example, DAP and urea and potash, all of them are minerals with a limited available resource, and we are fast depleting them. And if we are going to integrate this biofertilizers with the conventional fertilizers, and we are going to how to integrate this. So there is a case study where biofertilizer has been applied in tea plant, and this is the result where 100% recommended fertilizer, 100% recommended fertilizer with the biofertilizer, NPK consortia. Rhizodine is the brand, and 75% recommended fertilizer with the 2 metric ton of vermicompost, and Rhizodine is the biofertilizer, 50% recommended fertilizer. You can see the result. There is a significant increase in made tea yield. So around 4,837 kgs in 100% plus biofertilizer, whereas in control it is 4,038 kg. So, and also when you are reducing the fertilizer dose to 25%, the statistically it is stable, on par with each other. So there is a possibility of reducing 25% of chemical fertilizer in Indian system. This is 2-year data where successfully Toklai Tea Research Association has conducted in Duvas and Lower Assam. And the report says the quality of the leaf, fine leaf is increased, bud length is increasing, and internode length is increasing, and there are no much change in the soil pH and organic carbon, whereas the nutrient T quality in terms of nitrogen, phosphate, potash, manganese and zinc are increased. So what we need is the quality of the produce. So this is where we are missing. So the quality, if we want to improve, we have to integrate this biofertilizer with the chemical pesticide and chemical fertilizers. And the available nutrient in the soil also has been studied. When you are seeing this 346, you see this 100% recommended fertilizer with the biofertilizer, 346 kg of nitrogen per hectare, and compared to 329 in 100% recommended fertilizer, because biofertilizer is compensating the nitrogen fixation, phosphate that is 78 ppm and 105 of potash. So it is above the recommended fertilizer, and when you are reducing the fertilizer, the yield is not affected, quality of the produce is increased, as well as the availability of nutrition in the soil is increased. So when coming back to the policy in India, we have introduced in 2015 neem coated urea by reducing 5 kg. So it is working well among the farmers, and farmers are accepting it. And we have also introduced 2001 nano urea. And where we are standing, we have studied, I am also representing Varsha Bioscience as Mr. Bipin said, and we have effectively studied coating this nitrogen and phosphate microbes with DAP and conducted the studies with a shelf of around 18 months. There are no deterioration, and on paddy it is giving as equal result as that of the experiment that are conducted alone, like DAP and biofertilizer. So if there is a problem in combination of N bacteria with nitrogen, especially urea, it is a challenge. We need to go for green chemistry combination, whereas if we are successfully integrating this microbe with the DAP, we can introduce 40 kg bag of DAP in this country, as well as MOP. In fact, when we are integrating, 25 kg of MOP is becoming equivalent to 50 kg of MOP. So we have lots of potency if we are integrating, and the government policy, aggressive policy is also required to approve it. And more important for the integration is urea manufacturing is the largest CO2 emitter in the chemical industry, which emits 12.5 million tons of CO2 annually. And the mineral depletion I was talking about, and 11 states in US banned sale of phosphate because they feel that the phosphate is contaminating the water resources. Likewise, how we are feeling the nitrogen. And government also is spending 1.88 lakh crores of rupees as a subsidy. And if you are saving 25%, you can say how much we can save for the government. And nutrient quality and yield, improving the quality of nutrient production and increasing the yield is another parameter. And the biotic, I am coming back to the biotic and abiotic stress. And of late, phorate and carbofuran, when it was banned across the globe, and as well as chloropyrifos. Chloropyrifos is one of the important molecule that was able to contain these nematodes. And the nematode population, termite population, root grub population is ever increasing. Now, integrating this biopesticide, usage of biopesticides is becoming inevitable across the globe for the biotic stress management program. And eliminating the uncertainties, we need to introduce the virulent and high density microbial biopesticides, combination biopesticides, microbial metabolites. Dr. Lakshmi Narayana was talking to you about the microbial metabolites. And not only these herbicides, we have abamectin, spinosas, all these things are derivatives of microbes. So we have worked on ivermectin for some way back 30 years before, and it was not very successful because the output was very, very less. We expected 2 gram per liter, and we have got only 400 mg per liter. So it was not cost economic when we are comparing ourselves with the Chinese. And the combination biopesticide, already it is in the market, and FMC has registered this product in US as well as the Canada, Bacillus licheniformis and Bacillus subtilis. And Certis, they have come with the innovative product with the bacteriophage and Pseudomonas syringae. And these combinations are available elsewhere, not in India. And BIPA has represented this with the government of India. I only presented this when Dr. Malhotra was the chair in 425 RC meet, and the government also agreed. Now the combination biopesticide guidelines have come, and we will be soon seeing the registration of the combination biopesticide. Not only combination biopesticide, there are possibilities of combining the biopesticides with the chemical pesticides. Say, for example, few of the companies, especially Chinese companies, they are integrating the BT with the chemical pesticides. They are compatible, and we can do it if properly. If we are studying the chemistry and biological of these are both the entities, we can combine both of them. So coming back to the uncertainties, one is the temperature. This is the 100-year data so far in south bank of Toklai. I thank Toklai for this slide, and you can see there is a slight decline in the temperature, rainfall. So rainfall pattern is reducing. Around 200 mm rainfall is reduced in Assam, and there is a constant increase in minimum temperature. Post-COVID, if you observe it, before COVID it has started coming down, and post-COVID, critically if you see 2019 onwards, it is drastically reducing. And when you are comparing with the maximum temperature, there is within a century, we have 1 degree centigrade temperature is raised. And post-COVID, you see there is a stable temperature from 19 to 21, and again it is increasing because of the urbanization and human activities. So these are all the unknown variables. Now the known variable is the carbon dioxide elevation. So 1990 it was 265, now it is 2018 it is 411 ppm carbon dioxide. So these unknown variables are affecting the crop a lot. Say for example, tea was never got irrigation some 2 or 3 decades before. Now for every tea completion they are spending around 15 rupee per kg. So when you are doing this pseudomonas, when you are this is the saline zodiac soil. When you are zodiac soil, when you are combining pseudomonas with the recommended 50% fertilizer, the root length, shoot length, and root weight, shoot weight is increasing. Not only for the pH and also the stomatal opening as well as the water retention, all of them can be controlled with the microbes. So we are unlocking the technology, decoding the chemistry and biology, integrating the biological with the conventional molecules in an untraditional way. So I thank BASAI, participants and sponsors for giving this opportunity and conducting this meeting very successfully. Thank you very much.
Thank you, Dr. John Peter. An excellent presentation, I must say. And thanks for gracing the occasion on behalf of BIPA and filling in the shoes of KRK Reddy, the president, who is unwell, and we wish him a speedy recovery.